All right. Good morning, good afternoon, good evening, everyone. Welcome to this week's Global Network webinar. My name is Panya Yu, and I will be moderating this webinar together with my colleagues Alex Loshsky, Sean Lowell, and Howie Chen. This webinar is jointly organized by the Global Network of Data Officers and Statisticians and the Inter-Secretariat Working Group on Household Surveys. At the Global Network, we use our online discussion group to share knowledge on various areas of data and statistics. If you're not a member already, I invite you to join us. I will share a link in the chat box after this presentation. Before I introduce the topic and speakers, I would like to invite Howie Chen to say a few words about the Inter-Secretariat Working Group on Household Survey. Howie.
Thank you so much, Panya. First of all, huge welcome to our speakers. Thank you so much for taking time and accept our invitation to be here with us. And thanks, colleague Panya and Alex and Sean for, as usual, great collaboration to work together on this webinar. So a few words about the Inter-Secretariat Working Group on Household Surveys. It is a group that was established by the UN Statistical Commission in 2015. To work on three things. One is improve coordination of surveys at national, regional, global level. And second is and really encouraging taking up of the innovative approaches related to surveys and related to survey integration with other data sources. And third one is we still continue make a huge effort to advocate for the importance of household surveys. So today's webinar is really aligned with many aspects of our objectives, our mandates of the Inter-Secretariat Working Group, and then especially related to the innovative approaches. And we're also, over the years, we've seen great work done by our colleagues in Brazil. And then it's our really task to amplify their impact, bring their great work to the global level, and so others can also learn and communicate with them. And with that, I would like to hand it back to Panya. Thank you.
Thank you very much, Howie, for your introduction. Indeed, today we are delighted to welcome three speakers, Marcelo Pitta, Thiago Meireles, and Pedro Silva from the Brazilian Network Information Center, as well as the Brazilian Institute for Geography and Statistics. They will present on the topic of leveraging non-probability samples and organic data for producing public statistics. The use of non-probability samples and non-designed organic data for producing reliable public statistics is now a popular field of study and academic production. Such alternative data sources have been growing in importance due to the increasing demand for more timely and disaggregated data, resource constraints, and the increasing non-response associated with conventional probability sample surveys. Substantial body of emerging literature aims to enable official and public statistics producers to cope with the challenges presented by using such alternative data sources, namely the potential biases created by selection effects or undercoverage. The COVID-19 pandemic has also compounded this scenario and increased the difficulties already faced by statistics producers. In this context, some experiments were developed to produce public data from alternative data sources in the Brazilian Network Information Center, NIC.Br, a non-profit organization responsible for planning, evaluation, and monitoring of the use of ICT in Brazil. In this webinar, our speakers will present the approaches adopted in two projects developed to fulfill the information needs of policymakers and civil society for insights into internet usage and internet quality. So let me now quickly introduce our three speakers. Marcelo Pitta is coordinator of quantitative methods at the Brazilian Network Information Center. Marcelo is responsible for the coordination of quantitative process, including large national sample design and selection, field data collection control and quality management, data processing, development of new methodologies, including small area estimation projects and non-probability sample studies. Pedro Silva is Vice President of Science, retired principal researcher from the National School of Statistical Sciences of the Brazilian Institute for Geography and Statistics. Pedro presided over the International Statistical Institute, ISI, from 2015 to 2017. Pedro's main research interests include survey and sampling methodology applied to household business surveys, as well as the analysis of survey data. And Thiago Meireles is a data scientist at the Regional Center for Studies on the Development of the Information Society. Thiago works with survey research on internet and ICT and new technologies for collection and analysis, such as non-probabilistic sampling, georeference data, and machine learning. Before we proceed, I just want to remind you of some housekeeping rules. Our speakers will have 35 to 40 minutes to present, after which we will have a Q&A session at the end. Throughout the presentation, of course, as I mentioned, the comment box is always open, so write your comments or questions there. And during the Q&A session itself, you are highly encouraged to ask questions directly by using the raise hands function and by unmuting and turn on your camera. And once again, this Global Network webinar is recorded and will be made available on the Global Network. We invite you to continue the discussions there after the webinar. So with that introduction out of the way, Marcelo, Pedro, and Thiago, let me invite you to start your presentation. Thank you.
Thank you, Panya. I will share my slides and start the presentation. Can you see my slides?
Yes, we can.
First, I would like to thank the opportunity and the invitation to share these two experiences we've been carrying on CETIC.br. Thank you for the great introduction. I will start talking and explaining a little more about the CETIC.br work in Brazil. And I think I will pass by some subjects as you've already mentioned. Who we are. CETIC.br is a department of NIC.Br that Panya have already mentioned, a non-profit organization whose mission is to improve the internet in Brazil, its availability, quality, and use. CETIC.br is a department of NIC.Br that is responsible for the production of information and communication technology indicators about the access and use of internet by households, individuals, enterprise, health facilities, governments, ISP providers, and a lot other establishments and processes. We rely on traditional surveys for the production of our indicators. We rely on probability sampling from complete frames. We use all types of data collection, face-to-face surveys, telephone surveys, web surveys. But as already mentioned, we've been dealing with increasing non-response rates and increasing demand for more timely and disaggregated data, while dealing with decreasing resources. The amount of resource, the amount of budget we have hasn't increased as much as people want more timely and disaggregated data. On the other hand, it's been a while since non-probability surveys have come to rise. They are cheaper to collect, larger samples can be collected in less time, but with the cost of introduction of some types of bias, selection bias or undercoverage of the frames. In order to mitigate this bias and use this type of data, we chose to use probability sample surveys as a reference to weight this non-probability and found sample data that came to us. And using the methodology of pseudo-weighting. This type of methodology is model dependent, which adds complexity to the survey estimation and the dissemination of the results. During the COVID-19 pandemic, the the need for information grew, especially the need for information about ICT, the use of internet, the use of technology, because people need to be inside their homes, and policymakers and stakeholders wanted to know how they were dealing with the pandemic, how they were working, how they were buying goods in order to survive, in order to live, what they were doing. Social distancing made traditional face-to-face interviews impossible for most surveys. And our most important survey, that is the ICT household survey, that collects data about the use, infrastructure use and appropriation of ICT by individuals and households, was not possible to be carried out because it was a face-to-face survey. We went for alternative data collection methods. And with these new data collection methods, we usually deal with incomplete and partial frames. And it's critical to try to mitigate the bias and the problems that rise with the use of these incomplete or partial frames. I will present two experiences that are already in production. Those experiences started in the early 2020 because of the pandemic, but they carry on, and now they are in production. We are using them in order to collect data in a cheaper way, in a faster way, and they can be used to improve and to test for the use of new models and new questions in our traditional surveys. The first case is the ICT COVID-19 web panel survey. As I said, during the COVID-19, we were not able to collect face-to-face survey. Our most important survey is the ICT household survey, but we needed information about internet use by population in order to give information to policymakers and stakeholders about the use of internet, especially during the pandemic. So we look for a web panel in order to collect the data for the internet users. In Brazil, web panels are built based on internet users aged 16 years and older. This was the target population. This is the actual target population of our web panel surveys. The domains of interest of the survey were sex, level of education, region, age group, and socioeconomic status. The frame was a web panel of individuals maintained by a market research company, and a telephone list to reach those in least favored social classes. Usually, web panels don't have the poorest people as their respondents. So we look for an option to also have telephone lists to reach those in lower education classes and less favored social classes. The sampling design was a quota sample established based on the same variables we want as domain variables. And this first web panel, we contact more than 90,000 individuals in order to have a little more than 2,500 individuals as respondents. Well, as a reference survey, in order to estimate the pseudo weights of this web panel survey, we used our last ICT household survey, the ICT household survey of 2019. The target population is broader. The target population of this household survey are the Brazilian households and all the individuals 10 years and older residing in permanent private Brazilian households. The frame used for this probabilistic survey is the Brazilian National Statistical Office Census Tracts database from 2010, the last one available. The total sample size of this survey is around 30,000 interviews, and the sample design is a stratified multi-stage sampling of households and residents. In order to be able to do the pseudo weight estimation, some assumptions are required. First, both the probability sample and the non-probability sample need to be carried out for the same reference period. They should collect a range of variables in the same way. The variables that we will use to model and estimate the pseudo-inclusion probabilities that will become the pseudo-weights. They should address the same target population, and they should not have intersection of respondents. If someone is a respondent in the non-probability sample, this person shall not be a respondent in the probability sample. Well, in our case, the samples were not carried out for the same reference period. We need to adjust that. We collect a range of variables in the same way. We put the same questions in the non-probability sample panel as we have them in the probability sample, the reference sample. We do not know if they address the same target population, and we believe that because Brazil is a very big country, we believe there will be no respondent that will respond to the non-probability sample and the probability sample. Well, in order to mitigate these problems of reference period and then try to understand if they address the same target population, we went for a methodology. First, to estimate the size of the target population of Internet users 16 years and old, using data collected by the 2019 ICT household survey, updating its totals by the population projections for 2020. We estimate pseudo-inclusion probabilities for the non-probability samples using a logistic regression model with the variables that both surveys have in common, and we managed this to happen. And we try to identify the population represented by the respondents of the web panel survey through another model, a model of being the propensity of being an Internet user, calculated based on the ICT household survey, the probability survey. And we estimated the variance using Bootstrap after all these calculations. This diagram shows briefly what we did. First, we update the ICT household survey 2019 totals by population projections of the first quarter of 2020 that were available and released by the Brazilian NSO. This updated ICT household survey, we model the propensity of being Internet user using variables that were common in the ICT household survey and also available for the web panel survey in order to compare the distribution of propensity of being Internet user for the population in the probability sample and for the respondents of the web panel survey. After that, we estimate pseudo weights considering the whole sample of the web panel and with three different cutoffs: propensity of being Internet user equal or more than 2/3, equal or more than 3/4, and equal or more than 4/5. And compare the calibration factors for these four options in order to understand if the web panel survey respondents really represent the desired target population that was estimated based on the ICT probabilistic household survey. As you can see by the box plot, the distribution of Internet user scores in the web panel is very different from the distribution of Internet user scores from the ICT household survey. This means that the respondents of the web panel do not represent really well our target population. Comparing the calibration factor statistics, we chose to cut the population that is represented by the web panel respondents by 2/3, which means that our web panel, the non-probabilistic survey, did not represent the whole target population that we desired to. With this approach, we represented a population of 401 million, and the target population that we desired to be represented is 121 million. we lost almost 20% of the population that we wanted to represent by this non-probabilistic sample. And this is not and the population that is represented by the web panel is different from the target population in some very important factors. It's a population that's younger, as you can see by the age range, comparing the target population and the represented population. It's a richer population, more individuals in upper classes, social classes. It's a population compounded by more computer users than the target population, and they are more educated. The level of education is higher for the respondents of the web panel than for the target population. These results were released despite of this difference. The advantages of using the web panel was that data were collected in avoiding face-to-face interviews. During the COVID pandemic, it was not possible to collect face-to-face surveys. The whole survey from planning to data release took less than 2 months to complete. The cost of data collection was a lot cheaper than for a traditional face-to-face survey. It costs 2% than the cost of a traditional survey. The disadvantages were that the web panel frame recruitment is not meant to address a specific population, and it's not very clear. The market researching companies that usually put available web panels in order to collect the data, they don't detail, they don't tell you with detail how they recruit their panelists. Coverage issues remain, despite using a probability sample as a reference for weighting. The approach is model dependent. We use 2 models in order, one to evaluate the representativity, the other one to estimate the pseudo weights. Good models may not always be available. And explain this methodology and disseminate the results is very complex. Although we were very careful when we disseminated these results, we reinforce the fact that our results were not valid for the whole target population of internet users 16 years and older. The press usually don't remember that when they are disseminating the results. But the approach helped reduce selection bias, but the target population can vary across different data collection waves. Even though you have a web panel that can represent your target population as you want to, sometimes or every time you went for a collection of web panel, you don't know who will respond. Using the Internet User Propensity Score model to understand the representative of the panel respondents, the web panel has undergone 6 additional waves, introducing a different model with different DEMs, different subjects, different items to be collected. And for these six additional waves, 4 waves, the intended target population was not covered, but for 2 waves, we were able to collect respondents that represent the whole target population that we desire. But we are still carrying on with this non-probability web panel survey. It became a tool to meet the demand for new indicators. It's cheap, it's fast to collect, and it can be used to test questions and new subjects. For the 7th wave, that is in planning phase, the data collection company will include the range of propensity scores of being an internet user as a quota variable to be monitored, to be controlled. We hope this will improve the number of web panel surveys that are able to represent the target population of internet users in Brazil 16 years and older. Every year, a new ICT household survey is released, We need to keep doing that in order to update the Internet User Propensity Score model, and in order to evaluate the changes in the respondents in the web panel and the changes in the Internet use of Brazil. Some of the questions on new themes from the web panel that we carried out in the 6 waves before this one that is in planning were already included as models and questions in our traditional ICT household survey. The second case that is in production is the weighting of a non-probability sample to estimate internet quality indicators for Brazilian schools. Also, during the pandemic, the importance of internet connection for schools raised, because that's when people realized that teachers, schools, were not able to provide education as they should be, or as they need to be in the case of a pandemic scenario, in the case where the children could not go to school. So the importance of the quality of the internet in the schools became became an issue for the government. What's the problem? CIMET is a firmware and a software offered by NIC.Br for measuring the quality of the internet in a point of access. Any of you can go in the internet, in your computer or cell phone, look for CIMET and run a quality internet test. It provides speed measurements for download, upload, jitter, and latency. During the pandemic, the Brazilian Ministry of Education realized the importance of quality of internet in schools, and the ministry asked the schools to install the software CIMET in order to evaluate the quality of the internet for the schools in Brazil, for all the schools. But this was, it's not a policy, it's something that the ministry asked the schools to do. So all the software that is installed is voluntary installed by each school. So we have a problem of self-selection. We were asked to estimate the quality of the internet for the set of 4 Brazilian schools based on the available sample of the schools that voluntarily installed the CIMET. This is a non-probability sample of schools. When we looked at the amount of the schools that had already installed the quality internet measurement, the target population was defined as only the municipal or state public schools, because the private schools didn't follow the recommendation of the Brazilian Ministry of Education. Almost none private school had the CIMET installed. So the target population of this goal to estimate the quality of internet became just the municipal and state public schools in Brazil with computer and internet access. And we used the pseudo-weighting methodology in order to estimate the summary measures for the target population. What are the data sources? Internet quality measurements provided by CIMET. On April 5 of 2023, CIMET devices were installed in almost 50,000 schools. The probability or the reference in order to estimate the pseudo weights is the census database that is collected every year by an institute linked to the Ministry of Education of Brazil. The census database comprised more than 200,000 schools, of which more than 100,000 were municipal and state public schools with computer and internet. The challenges of this project are that the census database is big in number of records, more than 100,000, and variables. We have 119 categorical variables, and 113 numerical variables. Traditional variable selection for response modeling and estimation of pseudo-weights did not work. All variables would be significant because of the size of the database, and the use of brute force to accomplish a useful model for the weights is computationally intensive, but we used a brute force methodology that I will explain in a few slides. We used two different methodologies. First, random forest, used for suggesting the order of importance for each variable in a model to predict the symmetric device's existence, and a logistic model including variables selected according to their importance in the random forest model. And in order to select the best model, we compare 6 different statistics. We evaluate 6 different statistics: absolute deviation and relative deviation for numerical and categorical variables, and the number of categorical variables in the census for which at least one category has the 95% confidence interval estimates not covering the target, and the number of numerical variables in the census for which the 95% confidence interval estimates do not cover the target. These 6 statistics were used in order to compare the results of each model. And what we did was to estimate and calculate every model from no variables, just the intercept, to all the variables, and compare the results of these 6 different statistics, adding 5 variables at each new iteration. 5 variables, 5 categorical variables, no numerical variable, 5 numerical variables, 5 categorical variables, 10 categorical variables, 5 numerical variables, 10 numerical variables, 10 categorical variables, and so on until the end of the variables of the database. And we chose a model with better values of the selected statistics, the 6 ones that I chose, and a parsimonious model. This chart presents the number of variables with targets missed by 95% confidence intervals. You can see that for the variables with 5 numerical and 5 categorical, there is a big number of variables, and it begins to decrease and establish after the cutoff model with 5 numerical variables and 140 categorical variables. When it comes to percentage of variables with targets missed, it's the same. It starts big and decreases and establish after some point. The sum of absolute deviations per fitted model also starts big, decrease, and establish after 5 numerical variables and 140 categorical variables, the model that we chose. It's the same when it comes to sum of relative deviations per fitted model. And you can see in all the charts that there is no model that can eliminate the bias. Even the model with almost all the variables, categorical and numerical, there is still some residual bias. Well, despite the large size of the non-probability sample, estimates had to be bias correct. A naive unweighted estimates would have considerable bias. As an exercise, we select a simple random sample from the school census database of the same size as the non-probability sample, almost 50,000 schools. For this simple random sample, almost all the variables were covered by the confidence interval. Only 4 variables were missed, 1% of the total number of variables. The proposed weighting is a middle term between the number of the variables in the model and bias is still existing for some variables. We chose the model with 140 categorical variables and 5 numerical variables. We believe that this model is not perfect, but it's the most parsimonious one, and we can use that. Installation of the CIMET device to measure internet quality in Brazilian schools is ongoing. Every quarter, the database of schools with a device is updated, and the whole process of estimation using pseudo-weight is carried out. We've just run for this quarter a new model, and the number of categorical variables needed to achieve the same residual bias decreased from 140 to 90 categorical variables. Still, 5 numerical variables are included in the model, and we have already installed the CIMET device in 70,000 schools in Brazil. The idea is to disseminate the internet quality indicators by state, type of administration, and urban-rural classification of schools. I think that was fast. Thank you.
Thank you so much. Thank you, Marcelo and Pedro and Thiago, for your presentation. I see that the last slide also lists all the references that were basically used for these two projects. We will definitely share the slides and the recording after the presentation. So I invite everyone to go to the global network to consult those as well. Give me a minute now, as I am allowing people to turn on your cameras and your microphones to ask your questions. But I think while we wait, maybe Marcelo, let me ask the first question. In these two projects, what were the role of the Brazilian NSO in it? Were they collaborating with you? Were they helping out? Did they even have a role in that? I would be very interested to hear about your experience.
Well, during the COVID pandemic, we talked a lot, worked a lot with the Brazilian NSO. In this web panel, the first one, that was the start of this work with non-probability, design non-probability database. We included 2 questions from the Brazilian NSO, and we compare our results from the web panel with the results of the Brazilian NSO. And they needed to tabulate, to do special tabulations for us, because our target population are internet users, and not the whole population of Brazilians 16 years and older. We've been always talking to them, and we have some projects with innovation when it comes to use of different data sources. And also Pedro is from the NSO, and he is our consultant. He was very close to me when we are dealing with the problem. The problem was the first try, when we get the results from the web panel, we look at the results when it comes to the use of internet. The panelists, the respondents of the web panel were more connected, more, how can I say, they were really have internet users, different from the profile of the internet user that we were used to deal with when it comes to the probability ICT household survey. So we managed to use the model on the propensity of being internet user in order to correct or identify what part of our target population was represented. And it was during a lot of talks between me, Pedro, and other colleagues.
Excellent, thank you. I have now allowed participants to turn on your camera and to unmute yourself. Please, if you have any questions for our 3 speakers, please use the raise hand function, and I will call on you. I see a question from Diana. Please go ahead, Diana, with your question.
Thank you. First of all, congratulations, parabéns to the team in Brazil. I think you show, because many times in the network, we are talking about how the data is processed in the countries, and then we should take and optimize the technology to produce data. So this, what you have done, shows that this is possible in the largest scale of a continental country like Brazil. So congratulations for that. Then I'm thinking of the two projects. So the first one, as a representation of the population, I was thinking that maybe the instrument is the one that provides this bias, right? Because it's a web panel, and not everybody has the same level of computer literacy. So you have better answers in the younger population than in the olders. So that was one point that I wanted your perspective on that. And the second question, for the school projects, do you already have some specific indicators that you follow? Because for WHO, for example, we have a project that is running now in Europe for measuring different nutrition indicators like stunting, wasting, height and weight for children. Others like diversity in the dietary patterns. Do you work with the different, like Facultad de Saúde Pública in Sao Paulo or other institutions? And what are the indicators that you would intend to measure? Because I see a lot of potential in the schools. Thank you.
Thank you for your question, Diana. Concerning the web panel, we realized that for the first wave, the second wave, the third wave, the respondents of the web panel were younger, more educated, richer, more computer-intensive users, more internet-intensive users. But we changed the company for the fourth wave. And for the fourth wave of the panel and for the fifth wave of the panel, we were able to collect the respondents represented the target population as a whole. For the sixth wave, unfortunately, we came back to the point where more educated, younger, and richer people answered. That's why for the seventh data collection, we introduced as a quota control the propensity score of being internet user, the propensity of being internet user. We don't know if the company will be able to fulfill the quota for this variable, but we hope they will be. So we will manage to understand the representative beforehand, not after the data collection. Concerning the information about schools, we just collect data about internet use infrastructure in the schools. We have a probability big sample survey, ICT on education. You can find that in our website. There is information about the use of technology by the principals, by the teachers, by the students, the infrastructure that exists in the school, but it's a probability sample. This project, the second project, is a project that the Ministry of Education is trying to put in all of the public schools, at least public schools, a device to evaluate the quality of internet. Because it was clear during the COVID pandemic that a lot of schools, public schools in Brazil, didn't have the infrastructure that they needed to provide education during the pandemic scenario. Okay.
Thank you, Marcelo. Let me take a few more questions. So the audience, if you have any questions, do raise your hand or type them in.
I see a question on the chat.
Yeah, Pedro, if you want to take that. So let me read out the question. The question says, would you have any good tutorial or tools or package to recommend in order to learn and to implement such method?
Unfortunately, we have not reached that stage of developing tutorials, but the methods themselves are well explained in reports that Marcelo can point to on the website of the NIC.Br. We based our work on papers that are published in the literature, and the references to those are provided in Marcelo in the slides. And the recommendation I would make to you is to think that the hardest part is twofold. You have to include questions in both sources, both the non-probability survey and the whatever sources you use as reference, that you can use to anchor models of the propensity to be on the non-probability source. That's important challenge number one. And the second challenge is to actually evaluate through modeling these propensities and generating the pseudo weights that are needed for weighting the non-probability source. So there are challenges in terms of including questions and making sure you have data for modeling, and then the modeling itself. The first part is not described in papers very much. The second, you find good references in the literature to how to do the modeling and so on.
Excellent. Thank you so much, Pedro, for that resource, and thank you also for pointing us to the paper, Marcelo. Any other questions from the floor? Please raise your hand. Perhaps I'll ask a question from the registration form, if there's no question from the floor at this point. I mean, what struck me as very kind of significant in your presentation, Marcelo, was you mentioning that the first project, the web panel project, cost about 2% of what the traditional survey may cost, right? Which is incredible. This is magnitude. The difference is in orders of magnitude. It's not just 10%, 20%, 50%. It's this 2%, right? So I think one of the questions that kind of relate to that was submitted in the registration form was in the realm of quantitative methods and data analysis, what do you see as some of the most pressing challenges and exciting innovation in today's context? And how do you envision these influencing the future of data-driven decision-making?
I saw this question. That's a big one.
Can I take that?
Yes. Go, Pedro.
Well, the challenges are like this. There is immense pressure on people who are producing data to innovate, to use these new data sources. The pressures are legitimate. I'm not questioning them. But the challenge is that if you rely in a naive way on some of these data sources, the bias that you incur in estimating some of your most interesting target indicators may be large. And in our two examples, the naive inferences we could make by using the single data source would be not adequate, would provide inadequate estimates of the target indicators. The web panel example demonstrated this, and we had to adapt the literature methods we encountered by having this additional model fitted, and then saying and stating very clearly that our inference referred to a subpopulation of the internet users 16 and plus. And that is hard for people to understand. But we try to make that as a very clear statement as part of the dissemination. Still, some users do not get the full message. They only focus on the numbers you publish, and that's it. That is part of the challenge, statistical literacy of the user communities to understand. And on the production side, we will still need either probability samples or censuses or some other additional data source which has not been affected by similar biases to anchor some of our estimates and mitigate some of the bias. So NSOs and others producing statistics will still need to be making some of these probability well-designed surveys or censuses available in a way that others using the non-probability sources can make bias correction and produce improved estimates from these sources. So the challenge is telling people that it's not so easy to get estimates from these non-probability sources as some may think it is. It's not so easy. But it's part of our job. And, you know, we produce these things, we publish, we let people know of our findings, and that's the way knowledge evolves.
Exactly, a good point, right? It's not easy to just count on these non-traditional sources, and also these non-traditional sources need to be complemented by all the traditional sources as well, right? So the cost saving that is done by the web panel would not have been possible if not for kind of the official data that have also been produced at greater cost. Anything else you may want to add on this question, Marcelo and Thiago?
I just want to reinforce, we'll continue to need traditional data sources. The reference need to be traditional, need to be okay, need to be collected in traditional way.
Point taken. Diana, do you want to come back with another question or comment?
Actually, yes, because what you say about traditional data sources for population and of course, but we have just written an article about citizen science and its potential for the reporting for some sustainable development goals. And I would like to get your insights from your side, because with this study, we can see that, of course, we cannot trust every data in the internet. But let's say that you have, everybody has the power of including or sharing their data through their phones. So alternative data sets, I don't know, from citizen science, what do you think about that? I will share here the link to the paper as well.
I don't know the paper, but we've been trying to use private data, CDRs from cell phones, and in order to estimate internet use. But one problem with this type of private data is to have access to it. It's not easy. We haven't managed yet to have access to use this type of data. And the first panel, we need to use telephone lists, because not everyone has a cell phone, not everyone knows how to use a cell phone. So if you want to have results for the whole population, you need to think that some people will not be using technology. A lot of data that is collected through cell phones, computers, internet is based on technology that it's not available equally for everybody. Okay.
There is a very important paper by Xiaoli Meng, where the core of the paper, the argument is the following: bigger data sets are not necessarily better data sets for estimating some targets. If the propensity to be in your bigger data set is correlated, even mildly correlated, with the outcome you want to estimate for, you may have big bias even with very large data sets. In the paper, he demonstrates using data from the US elections that a properly designed, simple random sample of about 400 would have the same accuracy as a data set with 100 million. So while the challenges and the possibilities of these data sets are immense, care is still needed. Bigger is not necessarily better. It's not necessarily worse either. You have to think that the main message I wanted you folks in the audience to have is, this is not ready-made. Your data sets from these other sources are there. You should think about using them to your benefit to save on costs and produce data that may not be available elsewhere. But you need to think. You need to look at the data to see what is available there that you might, say, triangulate with other sources. And if you see a bias in the things that are commonly available somewhere else, there might be potential bias in the target. There is not additional information on somewhere else. So you might need to think harder about how to use your data to produce estimates which are not so severely biased as if you were to use them naively in the first, get the data, get the estimates, and publish. Okay, that's the message.
Thanks, Pedro. Actually, on this topic of bigger is not always better, and also what Diana mentioned about alternative sources of data, including citizen-generated data. There is also a question on the registration form about social networking site. The question says, is it possible to take samples from communities such as social networking sites and be considered a representative sample? I think I kind of already probably know your answer, but have you worked with social media or social networking sites before at CETIC? What are your reflections on that as a source of data?
No, sorry.
I've never worked with surveys from social networks, but as Pedro already said, it can be a big sample, but it is the target population you want to represented by this sample? That's the question you need to make anytime you have a sample from a frame that you don't know the coverage.
Mm-hmm.
It depends on the outcome too, as Pedro said. If your outcome is not related to the fact of using a social network, it's not correlated to it, maybe it can be used, but you need to test and to evaluate.
Yeah, point well taken. Let me see if I can take one last question from the floor. I invite participants to ask your questions live if you have any last question for our speakers.
If not, Panya, I would like to make a comment regarding one of the questions that were posted through the registration.
Yeah, absolutely.
The one regarding subjective, how subjective is the approach of using non-probability surveys?
Yes, please, Pedro.
Okay. So the issue, there was a question of whether the approaches we have used to deal with non-probability samples or sources is whether the inference we make is subjective. It really depends on how you see subjective as a description of approaches that involve modeling, okay? So a Bayesian statistician might say it is subjective if you produce priors for the parameters that are subjective priors and are informative in a way that it reflects your subjective understanding of the problem. We did not use Bayesian tools for inference here, but we used classical statistical models. In the sense of that we rely on models to making our inference, it is subjective because all modeling exercises are subjective to a certain degree. A statistician poses the model, checks for the properties of the model fitting, and then uses the model as if the model is true to describe the conditions that we see in the data. So it is subjective to this extent, but not more than that. We did use models. We are very explicit about the use of models in the way that they were used to develop pseudo weights that we then use to make the inference, calculate estimates and produce some uncertainty of the estimates that we produced. But they are not subjective in a sort of strong way. We didn't use prior beliefs to influence the estimation of our parameters in the model and then to subsequently make use of the fitted models to conduct the final inference. So it's classical statistical modeling in a sense, coupled with subsequent use of the pseudo weights as if they were probability sampling weights attached to the non-probability survey sources. Hope this helps people understand where we're coming from.
Yeah, that's a very important point, of course, Pedro, and thank you for that clarification. Thiago, did you want to add something?
Yeah, I have a brief comment about the sample size and the relation with Bayes estimates. With this school's study, we have a new sample, and we try to use this is around 50% bigger than the first one, and the results are slightly better. They're not really better, slightly better. The deviations are about the same, but we have a really small improvement in the number of variables outside the target, but a really small improvement.
Yeah, thanks for that, Thiago. I'm afraid we are already a few minutes after our allotted time, but this has been a fascinating conversation and presentation. We really, really appreciate you taking time, Pedro, Marcelo, and Thiago, to talk to us about these two projects, and we certainly look forward to following the second project, but also any future projects that you may have. And the Global Network certainly hope to host you some other time as you have more to share and more reflections on these innovations that you are introducing at CETIC. But on behalf of the UN Statistics Division, thank you again for certainly coming to speak to the Global Network members. And I also thank the participants for your questions and for taking time to attend. If I may ask for a small favor to everyone in the call, can I request that you, if possible, switch on your cameras and unmute yourself and join me in giving Marcelo, Pedro, and Thiago a big round of applause and thank them for the presentation.
Thank you.
Thank you so much, everybody.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you, Marcelo,
Yeah.
Pedro, and Thiago, and to everyone else. Look forward to seeing you at the next Global Network webinar.
Thank you.
Bye.
Thank you.
Obrigada, bye.
Bye-bye.